Alright, so we are going to be getting started with Chapter P in our pre-calculus textbook, and we're going to start in Chapter P, Section 1, and this first section, in fact this whole first chapter, is all going to be information that coming into pre-calculus you should already know. And so we're just going to do a really brief overview. These videos should be pretty short, it shouldn't take long to get through them. And we're going to be just refreshing some vocabulary that maybe you haven't thought about or looked at in a while. First off, we have a box here, and we're going to be looking at different types of numbers and properties of those numbers. So, for example, we have the natural numbers, which is just the numbers that we typically count with, 1, 2, 3, 4, and so on. We have the whole numbers, which is all of the natural numbers plus 0. So that's the only additional number here. We have the integers, which is all of the natural numbers. We also have 0, and then we also have their opposites. So we have the negatives, but still no fractions and no decimals. Then we have the rational numbers. Now, this category is sometimes a little bit confusing because we do have whole numbers like we saw before. We have the negatives and the positives, but we also have numbers that can be written as a fraction. However, that does not just include fractions. A terminating decimal, or a decimal that ends, is also a rational number. A repeating decimal, or a decimal that follows a pattern that repeats, like 0.3333 and so on, that also can be written as a fraction. If you type in 1/3 to your calculator, you'll get 33333 and so on. Next, we have the irrational numbers. Now, these are numbers that cannot be written as a fraction. So we have pi, probably our most famous irrational number. We have the number e, which most of you know as 2.71, so on. Or square roots of numbers that are not perfect squares, like the square root of 10. These numbers can also be negative, though we don't have a negative example here. Next, we have the real numbers. The real numbers includes all of the numbers we've seen before. So rational numbers, irrational numbers, all the numbers that you're familiar with. Then we have imaginary numbers. Those are only numbers with an I. So 2 is not an imaginary number. 2i is an imaginary number. Complex numbers include all of these. So it includes irrational numbers, and repeating decimals. We also have simple numbers like -2, but we also have things that are combined with a real part and an imaginary part. So this is a complex number here, 5 minus I. Next, we have a group of definitions here. Again, these are terms that I'm assuming you're familiar with, but in the event that maybe you've forgotten or haven't used these terms in a while, we're going to go over them briefly here. A set is just a group of numbers that fit a certain criteria. And then each number or piece to that set is called an element of that set. Now, we can represent sets using roster method or set builder notation. And then we can also look at sets and compare them. So we can look at the intersection of two sets, or what two sets have in common, or the union of two sets, where we just combine all the elements in two sets, or two or more sets. Now, most of you are familiar with absolute value. It's the distance from 0. We also have opposites or additive inverses. So, for example, a number that is opposite to one another would be like -3 and 3. Those are additive inverses. We also have multiplicative inverses, so that could be something like 1/5 and 5, so that when you multiply them, you get 1. A term is just a number or a variable. It's a single monomial. Coefficient is the number out front, so for example here we see -3 would be the coefficient here. And then we also have like terms, so things that can be combined that have the same variable components. I'm going to go ahead and flip the page here. Now we can look at the properties of absolute value here. Again, properties that you're familiar with. You can split absolute value between the fraction here, where you can look at it as a whole fraction or separate it. Same thing with multiplication. And that's about it. Those are pretty much all the properties you know. You know that what you get out of an absolute value is going to be greater than 0. And now let's look at some properties of real numbers. So we have the commutative property of addition, where you're just flip-flopping the order of what you're adding. Commutative property of multiplication, very similar, only with multiplication. Associative property of addition, the difference here is we're looking at 3 pieces here, and we have a plus b plus c, and we can regroup that and get the same thing. Again, very similar with multiplication. And then the distributive property, we're just distributing that a, so those two pieces are equal. We have the identity property of addition where we can add 0 and it doesn't do anything to our result here. The identity property of multiplication, again, we can multiply by 1 and it gives us the same thing. And then the inverse property of addition, we can add the the additive identity, and that gives us 0. And we can multiply by the multiplicative inverse, and again, we get the multiplicative identity here. So that's it for P-1. I really recommend doing some of the practice problems in your book, and we'll go over the rest in class.